Alright, hi guys, welcome back, and we're on lesson 3 now, so let's move on. So question 3, which decimal that's abbreviated as hex number is the correct 8-bit 2's complement representation of -25, and that subscript there is to denote base 10. So we've got options there. A is E7, B is DB, C is 19, D is E6, C is DA. You don't really need to worry too much about the dollar sign in front. It's to do with addressing. Basically, you need to know where these. In future we'll see. We need to know where how to address from and to. The memory, the bus, and the registers, and all that stuff. So. I will move on to that section in a minute. Not in a minute, in quite a long time actually, because we're going to be going through a lot of different stuff before then. But still, all right. So what we first need to do is, I think I've explained most of the stuff up to now. So I'm just going to jump in. I mean, we might as well have a look at this table that I've put out because we haven't seen it yet. That's basically hex. So, you can basically cram in 256 values in just 2 digits, and you can kind of see why that is here, because there's 16 values in 1 digit. So if you're going to want 2 digits, you're going to need 16 squared. So that'll be 256 digits for 2, just for the 2 digits there. That's pretty straightforward, I guess. So there is actually, it's kind of an algorithm to, and I think it's good to actually think about algorithms immediately, because everything computers do with algorithms. So I think I might have even come up with this myself, so that's good. There's my algorithm. Make number positive, make it binary, pad it out, flip bits, add 1, convert to hex. So instead of just ruling out options, I can't really do that this way. So we need to think now what to do. So this step is I don't know really, it's pretty easy I suppose, isn't it? We just let's go a bit further out actually. Make a number positive, so that -25. I dread to think what's going to happen here. Okay. Okay, nothing. So now it's positive 25. Alright, so there's the first step. Now we have the next step. Now when you're making a number binary, I'm not really too... Basically what you have to do is you have to draw out something in the kind of region of this. I'm not sure if I'm going to get this to work, we'll see. And maybe if I can just get in underneath there, I might be able to just do that. But basically, what you can see is you take the big, there's 2 ways to do this. You want to do it from the left to the right. I'm going to tell you how to. In fact, there's many ways to do this. I often think about this stuff. Okay, that's far too large, and it's gone back tiny again. And it's too small there. Let's make it there. Yeah, okay. Actually, I may as well just make it tiny. Actually, make it. Okay. Anyway. So what we'll do is we'll just try. What about this one? Let's just try taking that 25 and just getting rid of the biggest multiple of 2 that we can, and then we just subtract it afterwards. So there's a 1 there, yeah, because 16. I mean, we could have had 32 above that, but there's no point because 25 ain't big enough. So that's there, yeah. So then if we subtract that, we can see there's 9 left, right? Which means that's a 1 as well. So and we subtract that, so that means there's only 1 left. Because there's only 1 left. These are going to be zeros, right? Because there's only 1 left. So then that 1 goes, unsurprisingly, there. So we can say that 25 in binary is 11001. Now, what we need to do in the next step though is to pad it out. And the way to do that is we want to convert it, because in the question you probably notice it's 8-bit So we'll deal with the 8-bit first, and then we can go on to the 2's complement representation. So okay, so let's just do that, I suppose. So there's 5 there, aren't there? So we're looking at this number, are we? I think so. Yeah, and that should. It's still, it looks a bit funny like that. I would like to have it there. You know, maybe, just imagine. Maybe that's the thing. I'm gonna have to think of some notation for it, but I don't really want it. But you know what, actually, because that's the thing. I really would like those. You know, it really doesn't make sense, does it, to have it like. I'm just going to leave it like that for now. That does not mean. That just means that's just a delineate. Yeah, x does not mean times at the moment. It's just delineating, just so I can separate the, you know, the 4 bits out. And then what we need to do is flip the bits. So we basically just switch them all around. So what are we left with? We're at 1 1 1 0. Remember, if it starts with 1, it's negative. So this is you know. So this is now where, you know, we've got. That's 25 in 3 there, but now we need to make it negative, right? So we're actually describing negative 25 in hex. So so we can do that, right? Is that right? Look at that, right? Okay. Okay. Hopefully I'll get a bit more confident as we go along, but you know, it's a bit different when you're actually talking it. Because, you know, alright, so we're going to add 1 to this. Is that right? I think so. Okay, and that's basically it. Now all we have to do is we just go back up to our table and we look at 1110. Where's that? There it is. So we'll just put E there. And 0111, where's that? 7, and hopefully, okay, good. Yeah, so that's it. And therefore, I can conclude that A is the answer. Okay, thanks for your time, and see you in lesson 4.